Okay, for your response, 1991 AB3 says, let f be the function defined by f of x is equal to 1 plus tangent x to the 3/2 power, which is really the square root of that quantity cubed. And then it says for the interval from negative pi over 4 to pi over 2. So x has to be between negative pi over 4 and pi over 2 for this graph only. So what you call this is called a domain restriction. So the graph usually is for all real x, but they're restricting the graph, and it's kind of like, think of it as like a piecewise function, but it only has one piece. But they're just saying we're only going to look at the graph from negative pi over 4 to pi over 2. All right, part A, write an equation for the line tangent to the graph of f at the point x equals 0. Well, you need two things when you write an equation for a tangent line. You need a point, and we get the point by plugging that into the original equation. The point is always found by plugging into the original equation. And then you need the slope of the tangent line. Well, how do we find the slope of a tangent line? We use the derivative, so we're going to have to find the derivative at 0. And that's going to get you points on this for your response if you do both of these things. So we're going to have to find these two things. Well, let's start off with the point first. That's pretty easy. We'll just plug 0 into the original equation. So you're going to have 1 plus tangent of 0, 0 radians. We're going to raise that to the 3/2 power. Well, tangent of 0 is sine of 0 over cosine of 0. Sine of 0 is 0. Cosine of 0 is 1. So you got 0 divided by 1. So this will just be 0. So we're going to have 1 plus 0, which is 1 to the 3/2 power, which will just be 1. So f of 0 is 1. So my point then is the point 0, 1. My slope, I have to find the derivative first. So I'm going to have to take this function up here and find the derivative. So we're going to have to go, I'm going to go under here so I can use my room. So I'm going to go f of x is equal to 1 plus tangent x to the 3/2 power. And now I'm going to use chain rule to do this derivative. So just be careful when you do your derivative. So we're going to have f prime of x is going to be equal to 3/2 times 1 plus tangent x to the 1/2 power. Subtract 1 from the old exponent to get to new. Derivative of the inside would be derivative of 1 is 0, and then derivative of tangent is secant squared x. So there's my derivative. And now I want to find the derivative at 0. So I'm going to have f prime of 0. 3/2 times 1 plus tangent of 0, which we already did up there. That'll be kind of nice. We already did tangent of 0. And then secant of 0, and squared just means we got to take the whole secant value and square it. So secant squared x, you just find secant of 0 first and then you square it. So because the squaring is squaring the whole secant value. Tangent of 0 was 0, so that's going to be 1 plus 0 is 1. So we're going to end up with 3/2 times the square root of 1 is 1. And then in here, secant of 0 is 1 over cosine of 0. Cosine of 0 is 1, so you're going to have 1 divided by 1, which is 1. 1 squared is 1 also, so what we're going to get for a slope is 3/2. So there's my slope of my tangent line. So now I got my slope, I've got my point, so then my equation for part A would be y minus 1 equals 3/2 times x minus 0. There's my equation. Alright, and that's part A. Part B, it says take the equation that you just found the tangent line, or take the tangent line you just used. It says use the equation found in part A to approximate f of 0.02. So all I want to do is, well, that's just plugging that 0.02 in for x. So I'm going to have, and I'll explain why this is, because if you have a graph, let's just say, I'm going to just make up a graph, but let's just say you have a graph and it's right here. And let's say the tangent line is at this point. Let's draw a tangent line right there. The tangent line will approximate values for the graph that are relatively close. So for example, if you were to pick, say this point right here on this graph, and let's say you don't know this equation, but you know the tangent line. Well, the tangent line, if you pick points that are close to this point of tangency, so right here's the point of tangency, right? If you pick points close to the point of tangency, the tangent line will give you a fairly decent approximation of the actual value. See, the tangent line approximation is right here in blue. Well, that's not where that red dot is. So You know, and here in blue, there's the tangent line approximation, but over here is the actual value. So the tangent line can approximate. We'll talk more about that later, so if that doesn't totally makes sense, it's okay. So we're going to have y minus 1 is equal to 3/2 times 0.02. Okay? So then you just take out, you just do that in your head. So we're going to have, well, if you do half of that, it's, let's see, 3/2. Let's see, if I do that, it will be, it'd be half of 0.02 is 0.01, and then 0.01 times 3 is 0.03. So you're going to have y minus 1 is equal to 0.03. Add 1 to both sides. Add 1 to both sides, and we're going to have y equals 1.03 for your tangent line approximation. So you should label this y of 0. Guess they use f of x. Whatever. They use f of 0.02 is approximately 1.03 because you used the tangent line. You didn't use the original equation. If you wanted to know what the actual value was, you would plug into the original equation to find the actual value, and we could see how good our approximation is. The next thing is to use f inverse. We did this in another free response. Denote the inverse of a function. Write an expression that gives the inverse for all x in the domain. So we're still considering this domain. So this is what it looked like. I'm going to go to a new slide again. So we have f of x is equal to 1 plus tangent x to the 3/2. And remember, it was from negative pi over 4 to pi over 2. And what I want to do, I want to think about what the range would be. See, this was the specified domain, but what would the range be for this? Because the range is really going to determine what the domain for the new function is. Because when you do an inverse, you switch x and y. So when I switch x and y, you're actually switching the domain and range. Well, what is the range? Before I go any further, I already switched x and y. But what would the range of this thing be? Well, the range, you can plug anything from negative pi over 4 to pi over 2. That's going to give you values. If you think about the tangent graph from negative pi over 4 to pi over 4, it's a disco curve. And if I add 1 to that, it's still that disco curve. And if I take the cube root of it, square root or cube root of it, it's going to positive and negative infinity because it's going up and down forever. So the range is going to be all real numbers. Okay? So when I do this, the domain for the new function is going to become the range. So anyways, I switched x and y. Now I need to resolve for y. So I'm going to get rid of this 3/2 power, I got to take both sides to the reciprocal power, which will be to the 2/3 power. So I'm going to have to go this side to the 2/3 power. So we're going to have x to the 2/3 is equal to 1 plus tangent y. And then I'm going to subtract 1. X to the 2/3 minus 1 is equal to tangent y. And then I'm going to take the inverse tangent of both sides. So we're going to have inverse tangent of x to the 2/3 minus 1 is equal to y. Now the reason I took the inverse tangent is because inverse tangent will cancel this tangent out on that side. So really what I was doing, I'll kind of show that step in between here. I was taking the inverse tangent of this side, x to 2/3 minus 1, and I was taking the inverse tangent of the other side. But what was happening there is it was canceling out. Inverse tangent cancels itself out. So that's where I get the y equals. Now, that's my inverse. I've resolved for y. So now I can denote it. It's going to be f inverse of x is equal to inverse tangent of x to the 2/3 minus 1. And there's my inverse function. And the reason I'm doing the inverse is because it's different from this y value. This was the original function up here. This function is set equal to y, but we're going to denote that it's the inverse of y by putting that inverse notation. And then it looks like, no matter what you plug in for x, I can plug in negatives, positives, or 0 because it's to the 2/3 power. So I can plug anything in for x. So the domain would be all real numbers for this. And I think it even said that in the directions if you go back and look. So there's that free response.